Well, hello. Today we're going to be solving equations. Now, you might recall that an equation is a mathematical sentence stating that one expression is equal to another, and that a solution to an equation is any replacement of the variable that results in a true statement. Now, what that all means then, of course, is if we have something like 2x plus 4 equals 10, this is an equation. And we have two expressions. We have 2x plus 4, and we also have 10. They're equal to each other. And for example, hopefully, we also know that if x is equal to 3, that would be a solution. That's because if we substitute 3 back in for x, we would have 2 times 3 plus 4, which is 6 plus 4, which is equal to 10. So today we're going to be working on solving some more equations. Now, as we do this, if possible, you should really simplify the expressions on each side of the equation as much as you can. This means that we're going to distribute if there are any places to do so. And you also want to combine like terms if they exist. So for example, in the previous one we did, there really weren't any like terms on one side of the equation, but there was a 4 and a 10 on the other. Now both of these are constants. They don't have a variable to them, so they are like terms. You could also do something like if we had 2x plus 3x plus 7, well, we know that the 2x and the 3x, those are like terms, and those could combine to be 5x. We also want to move all the terms with variables to one side of the equation using addition and subtraction. And we want to make the coefficients of the variable 1. So that if you end up with 2x equals 9, let's do even nicer. So 2x equals 10. We want to get that left side, or the side with the variable on it, we want to get that equal to 1, and I would do so by using an inverse of multiply, which is to divide, and now I have 1x equals 5. Answers can always be checked then by plugging them back in or substituting them back in. Okay, let's do a few examples. These are multi-step equations. So I have 5x plus 2 equals 57. Now, whatever I do to one side, I do to the other. So the first thing that I'll do is I'm going to try to combine my like terms by subtracting a 2 from both the left side and the right side. This will be then 5x equals 55. And after that, I'm going to divide both sides by 5. So if we divide the left side and the right side by 5, that will isolate the value. Now I have 5 divided by 5 becomes 1x, which is what we wanted. We do have 1x equals 11, or just x equals 11, as a lot of people would probably say. On number 2, I'm going to notice here that we have a negative 5 on the left and a positive 1 on the right. So we can add 5 to both sides of this equation so as to isolate the variable. If our goal is to get this into just a 1x, the first thing we want to do is get rid of this negative 5. So I'll add a 5 to the left side and to the right side of the equal sign. Negative 5 and positive 5, those will simplify to be 0, or they'll combine to be 0. Now I have a negative 6x equals positive 6. My next step then would be to divide both sides by a negative 6. So I'll divide the left side by negative 6 and the right side by negative 6. Over here I have negative 6 divided by negative 6 is a positive 1. That's what I wanted. And then I have equals negative 1. So 1x equals negative 1, or in other words, x equals negative 1. Down here you can see we have more terms. On the left side of this equal sign, I have 5x plus 3, and on the right side I have 2x plus 15. So I have 2 terms on the left side and 2 terms on the right side. I'll start out just like I did before by using some inverse operations. I'll subtract a 3 from the left and a 3 from the right. Now, positive 3 and negative 3, those will combine to be 0. And if it's 0, you don't really need to write it there, but I'm going to choose to do that. Over here I have 15 minus 3 is 12. Now, I like to use the space that I have. So I'm going to come back up here and say minus 2x on the right and minus 2x on the left. These will combine together to be 0. And on the left-hand side, 5x minus 2x is 3x. And when you look at what we have and you get rid of the things that don't matter or the zeros, what I have on the left side is just 3x, and what I have on the right side is 12. Now, I like to do it this way because it saves a little bit of space. But I do want to show you that you could do this through the course of several different lines of work. So you still might start out by subtracting a 3 from both sides of the equal sign, and that will get us 5x equals 2x plus 12, and then this is 0. Again, you can choose to write it or not. The next thing you might do then would be to subtract a 2x from both sides of the equal sign. And then I have 5x minus 2x is 3x equals 12. And we're right back there. It just took us one more line to do it. That's totally fine. After that, we'll go ahead and I'll choose to divide both sides by 3. Oops. And then I get 3x divided by 3 is 1x. That's what we wanted. And 12 divided by 3 is 4. So I get 1x equals 4. Or you could just say x equals 4. That's fine as well. All right. Our next one then, you can see it's a very similar situation. As always, I would encourage you to try to do this on your own. Pause the video, work ahead, and then just skip to the parts to check your answer or listen for some explanation. On the left side here, I have 6x minus 5 and 7 plus 2x. Now, it does not matter if I decide to add a 5 to the left and a 5 to the right. That would work because negative 5 and positive 5 will combine to be 0, and this would be 12. Another thing that you could do if you wanted to, just because some people are a little concerned, like, oh, I didn't think to do it that way, you could say, you know what, I want to subtract a 7 from both sides. That's just fine. There's nothing wrong with that at all. What will happen is those combine to be 0. Negative 5 and negative 7 combine to be negative 12. And then remember, my goal is to get all of the x's or all the variables on one side and all the constants on the other. So I could then subtract a 6x from both sides. Now, is this the way that I would always do it? Probably not. I like to make my addition and subtraction a little easier than this. But those do combine to be 0x minus 12 equals 0. And then 2x minus 6x is negative 4x. When you forget about all the zeros, or we kind of clean these up, I have negative 12 equals negative 4x. And then we'll divide both sides by negative 4. Now, if you did it the first way I had it, you should have still gotten x equals 3, and this time I have 3 equals x. That's the same thing. Okay, so if you have 3 equals x, or if you have x equals 3, it doesn't really matter. That's the same. You should always plug these back in to make sure that they work. I'm going to trust that I did it right, though. Let's go on to a few more that have a couple additional steps to them. These look a lot more intimidating because there's more terms involved. Well, we just need to make sure we kind of follow our strategy, which is to try to get all of we combine the like terms, and then we'll move the constants to one side and the variables to the other. So on this left side, I'm going to note the fact that I do have a 6x and a negative x. Those are like terms, and they will combine together. So 6x and negative minus 1x. I know it just says negative x, but that's a negative 1x. So that will become 5x. And I'll go ahead and write my 1 there. On the other side, the first thing that I'll do is something that many of you probably know, and that's to use the distributive property. I'm going to distribute this 2 to each of the terms inside the parentheses. To distribute means we're going to multiply them. I have 2 times 10x. That will be 20x. And I have 2 times -1 will get us -2. Notice there are no other like terms to combine on each side of the equal sign. But what I will do next is to begin to say, well, I think I'll add a 2 to both sides. I don't know why. If I have the choice to add, I'm probably going to do that most of the time. So we'll go ahead and add that over. We'll do a little simplifying. What I have is 5x plus 3 equals 20x. And then -2 and +2 combine to be 0. Next, I'm going to move the x's from the left side over to the right. So I'll subtract a 5x from the left and subtract a 5x from the right. What I have left then is a 3 equals 15x. I'm really close to being done. My goal is to have this be just 1x. So I'll get that by dividing by 15. So I divide the left side by 15 and the right side by 15. Now 15x divided by 15 is 1x. That's what we wanted. And 3 over 15, well, that's a fraction. It's not going to can't just get rid of it. You'd put it in a calculator and get 0.2. But the other thing that I can do is I know that 3 and 15 have a common factor of 3. So if I divide the top and the bottom by a number that goes into both 3 and 15, that will equal 1 on top, and 15 divided by 3 is 5 on bottom. So what I get is 1x equals 1/5. Now I know that's not a really nice number, whatever that means, but a lot of people prefer to not have fractions in their answers. I think it's not so bad though. All right, number 5, this one over here to the right, is almost identical to that. Right? As we look at this, you can see I have a 7 times this quantity. This x plus 1 is being multiplied by 7. I have 7 copies of those. So my first step is going to be to distribute this 7 to both terms through multiplication. This will be 7x plus 7 on the right-hand side. And on the left-hand side, I just have 4 plus 7x. Now something interesting is going to happen here because I'm going to subtract the 4 from both sides so that I can work on getting my x's alone. Right? So on the left-hand side, I'll have 7x equals 7x plus 3. Some of you already see what's going to happen. When I subtract this 7x from each side now, I end up getting 0 equals 3 because those will each combine to be 0. Now this doesn't say like x equals 0. This 0 equals 3, but that's not true. This is a no solution. Right, so we'll go ahead and just write out no solution. There's a couple of ways that you could indicate this to somebody to say, hey, it's impossible that there's no number that works for this. You could say no solution. That's my preference. Some people like to use this symbol. This is the null symbol, and this just means that there's no solution. That is not the same thing as 0, mind you, because 0, like for example, it could be 0 degrees outside, but it can't really be null degrees outside. So please don't use those interchangeably. The null symbol is not 0. Okay. Also, you might see some people write it like this, where they say, I'm just going to put a couple brackets and leave them empty. It's called the empty set, and that really is it's kind of the same thing as just saying the null set, right? The empty set, there is no solution. My preference is to just say no solution. There's no number that you could plug in for x and cause this to be a true equation. Okay, so nothing works for that. This is a good chance to, once again, pause the video and work ahead. on this next equation, I can see I've got a 2 times the quantity 3x, or sorry, 3 plus 4x. So my first step will be to distribute. I'll multiply this 2 times both of those. That will give me 6 plus 8x minus 6 equals 48. Let's identify some like terms. Notice here, there's a common mistake that people make, and that is they'll try to add a 6 to both sides. The problem is I didn't add 6 to both sides. I actually added 12 to one side because this equal sign right here is what determines our sides of the equation. So now you can clearly see I've actually added 12 to this left-hand side. That's not what we want to do. So instead, let's just combine the like terms. These are both, this 6 and this negative 6 are both on the same side of the equal sign. If you need to, draw this vertical line here so you can identify the two sides of the equal sign. But 6 and negative 6, those combine together to be 0. Right? So that just becomes 8x, and the 6 and negative 6 cancel out. Now I have 8x equals 48. My next step would be to try to divide both sides by 8, and that will get me then 1x equals 6. So just x equals 6 is a good answer for this one. As with the others, you could plug it back in to make sure that it works. Should be good. On this next one here, we've got quite a bit going on. There is a sneaky little thing here with this equal or with this minus sign, and that's because we're subtracting this whole quantity. We're subtracting 2x plus 2. So what works well for something like this is to take this negative and distribute this negative. Almost treat this like this is negative 1 times that. Now, I'll multiply that to the first term inside the parentheses and to the second term so that we can say I've got 13 minus 2x minus 2. That's on the whole left side. And then on the right side, I've got 2 times x and 2 times 2. This will be 2x plus 4 plus 3x. The next thing we're going to do is, once again, identify any like terms. Try to simplify each side of the equal sign as much as you can before moving things from one side to the other, before using the inverse operations. So I see that we have, we've got a 13 and a negative 2. Those will just combine to make 11. Okay. Notice that I didn't say like, oh, let's do plus 2x and plus 2 or plus 2 plus 2. That's not right. We don't do it that way because these are both on the left side of the equal sign. Okay, the equal sign is over here. I didn't actually add 2 to both sides of the equal sign. I actually added 4 to the left side, nothing to the right. So please don't do that. That's why it's important to know where that equal sign is and just combine the like terms. Okay. Let's keep going here. Over on the right-hand side, we do have a 2x and a 3x, and they're both on the same side, so those can combine together to make 5x. Next, I'm going to choose to add a 2x to both sides. I told you I always like to add. I find that a lot of people prefer to add over subtract, but I don't have any data on that. I guess that's just my personal experience. And now, I still have this, I have a 7x on one side. That's cool. The x's are all on one side, but I do have a 4 that I'm going to go ahead and subtract from both sides. And that will make then 7x on the right, and 11 minus 4 is 7 on the left. So 7 equals 7x. But my next step then would be to divide both sides by 7. 1x equals 1, or just x equals 1. And if you were to plug that back in, it should work. All right, the last couple of these, you can see we've got that number 8 coming with a fraction. We'll get to it in a minute. Down here, I'll go ahead and I'll choose to add an x or add a 1x to both sides. Negative 1x and positive 1x, those combine to be 0. Right. So 5x equals 2x. Now, there's something else I could have done, and hopefully you see it. Couldn't I have combined some like terms? I probably should have done 5x minus 1x, but this will also work. I just kind of want to show you, sometimes we get in a habit of just doing things on autopilot, right? And this, now I have 2x equals 2x. Whew. And then I can, well, let's see, do I divide? Nope, because I don't have all the x's on one side yet. You want to get all the x's to one side, and then we'll work on turning it down to 1x. So I'll subtract a 2x from the right and subtract a 2x from the left. And what I get then is 0 equals 0. This is called an identity. It just means that any number you substitute in for x is going to balance the equation. Every number is a solution to this. I do want to go back up here though and show you how we could have done this maybe a slightly different way. And that would be to notice that I have a 5x and a negative x here. That becomes 4x. And over here I have an x plus 3x. When I combine my like terms, I get 4x. Okay. Then I would go through and subtract a 4x. This is probably a little cleaner. I get 0 equals 0 this way, and we have identity. Now this last one here, again, I know there's a fraction involved, so right away some people are a little bit concerned with it. The first thing that we're going to do on this problem is to distribute our 1/4 to both terms inside the parentheses. Now when I do this, this first part is just 1/4 x, that's easy. But now I have to take 1/4 times 2/3. Remember, when we multiply a fraction, we can multiply straight across the top and straight across the bottom. That'll get us a 2 on top and a 12 on bottom. Now for now, I can just leave it like this. I could reduce this to 1/6, but I'm going to choose to leave this as 2/12 for now. The next thing we're going to look for is we're going to clear the denominators. In order to clear the denominators, what we want to do is find the least common denominator. I can see I have a 3, a 2, a 4, and a 12, and I need to find a number that all of those will divide into evenly. Hopefully you can just kind of look at it and say, you know what, I know that all of those numbers they're all factors of 12. So 12 is our least common denominator. I'll go through and multiply every single term times 12. When I do this, I'm going to write it as a times 12 over 1, just so that I remember this is actually a fraction. Once again, when you multiply fractions, you can do this a couple different ways. You can multiply straight across the top and get 12 over 3 x, and then over here I get 5 times 12 is 60, and then 2 times 1 is 2. I have 12 times 1 is 12, and 1 times 4 is 4. And then here on the end I have 12 times 2 is 24, and 12 times 1 is 12. Now, because I found the least common denominator and I am trying to clear the fractions, all of these are going to divide out evenly. They're all going to divide into some real nice numbers. 12 divided by 3 is 4, so this will be 4x. 60 divided by 2 is 30. 12 divided by 4 is 3, and then I still have my x there. And then 24 over 12, or 24 divided by 12 is just 2. Now there's no more fractions. By multiplying by the LCD, we were able to get rid of all of the fractions. I will say that back up here in this step, when I multiplied by 12, there are some people that would say, I know that 12 and 3 reduce down to 4, and so I just have 4x. You go straight to that step. And on the next one, you'd say 12 and 2 reduce down to 6 and 1, And of course, 5 times 6 is 30. And 12 and 4 will reduce down to 3. And 12 divides by 12, and you're left with just that 2. So you can absolutely do it that way. I have no problems with that. The more comfortable you are with fractions, the easier stuff like this becomes. From here, though, we are going to move all of the x's to one side. I'll subtract a 3x from both sides of the equal sign. And then I will also subtract a 30 from both sides of the equal sign. Keep in mind that equal sign is right here. And when we do that, we have 4x minus 3x is 1x. The 30 and the minus 30 cancel out. 3x minus 3x, those will subtract down to 0. And negative 2 minus 30 is negative 32. X equals negative 32. You can substitute that back in to verify that it works. This one's pretty ugly to put back in though, because we do have that 1/3 times negative 32, but that should work out well for you. The next thing that we're going to look at is whenever we want to solve problems in math, sometimes people just don't know where to start. And so I would encourage you, first of all, read the problem, right? Read a problem, make sure you understand it. Mark up the text. Okay, do some underlining, do some highlighting, circle things, draw some arrows. Okay. Then also you want to try to organize the given information as best you can. Maybe you want to make a list. I love drawing pictures. Definitely encourage you to do that. Okay. And then also write an equation that represents the scenario or that models the scenario. Then you'll want to solve and make sure that your answer makes sense. Sometimes we get an answer and it just doesn't make sense. And we feel, hey, this answer doesn't make sense. That's definitely time to go through and reevaluate what you did. And again, just trust your gut. If your gut says, man, something's wrong, ask for some help or find another way, try to solve the problem a different way. I do want to take a minute and go back and re-emphasize this first one, though. Read the whole problem. The reason I say that is because there's sometimes whenever people don't really understand what the question is asking, they get so excited to just go through and start marking up the problem that they don't actually read what the question is asking. So please make sure you understand, what should my answer look like? Am I solving for a number of cars? Am I solving for how fast a car is going? Am I solving for a number of hot dogs eaten? Am I solving for a number of hot dogs eaten per hour? Like, make sure you understand what the question is asking. So please read it and identify the actual question. Okay. All right, let's try to use some of these tactics to translate some problems and solve. So 5 times the sum of 3 and twice a number is 70. Find the number. Okay, so I do know that when it's all said and done, this idea of find the number, my answer is going to be something like 12, right? Or 30, -2. I don't know. But I see 5 times. Okay, so that's something important. 5 times something. What am I going to be taking 5 times? Well, I'm going to be taking it times the sum of 3 and twice a number. Then another thing that I see is very important is this word is. When I see that word is, I know that that's math, right? That's math for equals. Or I should say that's English for equals. And then I also have is 70, right? So 5 times, that just means 5. And I'm going to be multiplying it times the sum of 3 and twice a number. Well, twice a number would be 2x. And it says the sum of 3 and twice a number. So I need to add those together. Well, if I have to take 5 times that whole amount, hopefully we've done enough of these previously that you would need to know I have to put that in parentheses. I need to take 5 times that whole quantity. And then, of course, we do have, we have equals 70. So when I write this all out in one line, 5, and then times the sum of 3 and twice a number is 70. There. We wrote this out we wrote this out using some numbers and variables. Okay, we're ready to solve. There's a few ways to solve, but if we keep doing this the way we've done previously, I'll just take this 5 and distribute this in. If you're wondering to yourself, could I have divided both sides by 5? Yes, you could have. But this will become then 15 plus 10x equals 70. Then I'll subtract a 15 from both sides and get 10x equals 55. The next thing that I'll do then is to divide both sides by 10. And that's how I get x is equal to, now this seems like it's not a very nice number, and that's okay. It's not going to be an integer. That's okay. So 55 over 10, I've got to ask myself, what goes into both of those? I know that a 5 does, so I'll divide the top and the bottom by 5. This will become 11 over 2. This is a perfectly acceptable answer. If you go ahead and you take 11 and divide it by 2, you'll get 5.5, so 5.5. This could also be written as 5 1/2 if you wanted to write it as a mixed number. Okay. All right, let's do that again here. So 2 more than a number is 12 less than 3 times the number. Find the number. So once again, ultimately, this is my question. Find the number. Find what we can do this for. So let's start breaking it down. We have 2 more than. Well, that means that we're going to be adding 2 to something, right? 2 more than a number. So some number, and then we want 2 more than that. Well, I'll use n this time. A lot of people like x. I'll use n this time. Is. Ooh, that one's nice. That's kind of the middle, right? That's going to be my equal sign here. So I'll put equals. And then we have 12 less than. Now, a lot of people think this means 12 minus something. That is not what that means. Okay, so I'm going to get rid of that for now. So 12 less than 3 times the number. Let's see here. Let's go to 3 times the number. Sorry, I guess I'm reusing my colors. So those are the main parts of this. 2 more than a number. If I have my number and I want 2 more than that, I could say plus 2. Then I have is. This next part is weird because it says 12 less than 3 times a number. And the mistake that so many people make is they say 12 less than and then 3 times the number. This is wrong. Okay, I don't even like having it on my screen. You see, this says start at 12 and then take away 3n, but that's not what 12 less than a number, 12 less than 3 times a number means. We actually have to switch this around. We have to transpose this, and we're going to write it like this. This is one of the most common mistakes that people make. What we need to do is we're going to say we start with 3 times the number, and we want 12 less than that. So 12 less than what? 3 times the number. There we go. Now this says 12 less than 3 times the number. Okay. All right. From here, this is relatively easy, hopefully. Let's get all of our n's on one side. So I'll subtract an n from both sides. Remember, this is a 1n. right? And n minus n, those will combine to be 0. Now I have 3n minus n. Remember, this is in fact 1n. We don't always write it that way, but it is 1n. So 3n minus n is 2n. Let me just bring this negative 12 down. Just bring this down. Okay, let's go ahead and I don't really need this equal sign here. We'll get rid of it. After that, I'll add a 12 to both sides, just like this. And what I have is 14 equals 2n. My last step, I want this to be a 1n, so I'll divide both sides by 2. Now I get 1n equals 7, or n equals 7. Don't forget, you can write it as 7 equals n, or n equals 7. Okay, it doesn't matter which side of the equal sign they're on. A patient receives 3 doses of medication over 3 days. The total dosage administered over the 3 days is 450 milligrams. If each day's dose increases by 50 milligrams, how much medication did the patient receive on each day? Okay, so when we look at this problem, the actual question is how much medication did the patient receive each day? Our answer is going to be some amount of medication, and I notice that it's in milligrams, so my answer is going to be some number of milligrams, right? It'll be some number of milligrams of medicine. Maybe it'll be like 50 milligrams of medication. I don't know, but I do know that I want an answer that makes sense. If I get an answer like negative 43 milligrams of medication, I probably did something wrong. Okay. If I get an answer like 10 billion milligrams of medication, again, I probably did something wrong. I'd want to go back and revisit that. So there's a lot going on here. So there's 3 doses, right? That means I'm going to be adding 3 numbers. I'm going to add something plus something plus something. Okay. And then it also says the total dosage over the 3 days is 450 milligrams. Okay, so the total dosage, and then we have this word is, that's our equal sign. And if I add up the medication that I have the first day, the second day, the third day, those are going to add up to be 450 milligrams. Okay. It says each day's dose increases by 50 milligrams. Ooh, this is tricky. See, if it was the same dose, what I might say is something like this. I'd probably say, let X equal the number of milligrams of one dose. Okay. And then what I would do is I would just say like, well, this is probably just X plus X plus X. But that's only true if it's the same amount every day. And it's not. So here's how I'm going to get around this. Instead of saying let X be the number of milligrams of one dose, I'm going to make a slight adjustment on this. And I know that seems silly. Like, man, why are you taking the time to write this out? Let X be the number of milligrams of the first day's dose. Okay? Because here's why. If I can figure out the first dose, if I figure out that that's like, I don't know, 10, and then the next day is 50 more. So it'd be 10 plus 50. So the next day would be 60, right? Maybe it's 10 plus, the next one is 50 more. So that'd be 60. And then I need 50 more than that. So 50 plus 60 is 110. Well, clearly those don't work. That's not quite right. Okay. And that's okay. I could sit here and guess, right? I could say, well, what if this one is 50 and the next one's 50 more and the next one's 50 more than that? Do those add up? Do those work? Well, notice what I'm saying is I have the first amount and then this next one is actually just the first one plus 50. right? And then the next one is actually the previous number plus 50, right? So what if I did this? What if we said the first day is x, the next day is x plus 50, and the next day will be 50 more than that, right? So I have x plus 50 and I need 50 more than that. That's x plus 100. That's what that's going to look like. So I have my first day's dose, my second day's dose, and my third day's dose. Each one is increasing by 50. And we can verify that once we get our answer. Okay, so if we go through and combine our like terms now, so I have x plus 50 plus x plus 100 equals 450. When we combine our like terms, I get 3x plus 150 on the left-hand side equals 450 on the right. I'll subtract, sorry, so I'll subtract 150. I get 3x equals 300. And then lastly, we'll divide both sides by 3 and get x is equal to 100. Now, specifically, it's 100 milligrams. Now, if you go back and we plug this in, let's make sure this makes sense. If I actually put 100 in here, and then if I put 100 in here, this is 100 plus 50. And then this one would be 100 plus 100. Because I know some of you were a little confused about why we went x plus 50, x plus 100. Let's make sure it makes sense on the back end. This is 100. This is 150. Notice it's 50 more than the previous day. And this one is 200. Notice it's 50 more than the previous day. Or in other words, 100 more than 2 days prior. They do add up to be 450, and then that's how we can verify that yes, this is correct. 100 milligrams is the first day's dose. Now, have I answered the question? Nope, I didn't. It says how much medication did the patient receive on each day? I can't just circle 100 and be done, right? So what I might say is something more like this. Day 1 was 100 milligrams. Day 2 is 150 milligrams, and day 3 is 200 milligrams. There. Now, how much medication did the patient receive on each day? Yeah, it's some number of milligrams, and I've identified how much they're going to be receiving on each day. Okay. So that's why it's so important to read the questions, make sure you're answering the question. All right, just a couple more. A rectangular hospital room is being prepped for a new patient. Ooh, I like to draw a picture for that. So let's do this. There we go. The length is 3 meters more. Ooh, here we go. Let's identify this. So the length, and then I see this marker is, that's my equal sign, right? 3 meters more than twice the width. Okay. So 3 meters more than twice the width. Okay, I think I can make an equation out of that. I can say the length, and then I have is 3 meters more than twice the width. I like to do it like this, twice the width, and now I want 3 meters more than that. So we'll say plus 3. So here's my first equation. First equation is L equals 2W plus 3. The length is twice the width plus 3, or 3 more than twice the width. Yeah, I think we're good there. Let's get rid of those. It also tells us the perimeter is 54 meters. Like, that's cool and all. I know that when I have a rectangle like this, I can say that like maybe this is the length, this is the width, this is the length, and this is the width. And then what I could do is I can use substitution. Instead of calling this length, I know that the length is twice the width plus 3. The length is twice the width plus 3. So I can get rid of that. There. Now, when I have what I have here for this rectangle, I have every side identified, right? You see, this side is the width. This side is the width. This side is twice the width plus 3. And this side is also twice the width plus 3. Okay. By the way, if I'm going to use L and W, like these are pretty common, but it is always a good idea. It's good to say like, hey, let's let the L equals the length of the room in meters. And I'll say that W is the width of the room in meters. See, the reason we identify these variables is because the more variables we have, we want to make sure we know exactly what we're talking about, and we communicate that to anyone else that might need to look over our work or that we might have to explain something to. Now we know that anytime we use L in this problem, we're talking about the length of the room, and anytime we use W, we're talking about the width of the room. The next thing that we're going to identify is that the perimeter is 54 meters. There is a formula for perimeter. It says that the 2L plus 2W equals P, equals the perimeter. And that's fine. Like, you can absolutely do that. The other thing we could do is we can actually just add all these up. I can add this side plus this side plus this side plus this side. I could just write those in one long equation, and then it would just be W plus 2W plus 3 plus W plus 2W plus 3. And the perimeter is 54 meters. There. Now I have all 4 side lengths of my room, and they add up to be 54. When we look at combining the like terms, we combine all the W's that are on one side. I have 6W, and we combine the constant that's on there, and we have 6W plus 6 equals 54. I'll subtract a 6 from both sides. Get 6W equals 48. And then I'll divide both sides by 6 to get W equals 8. Now I boxed it and I move on, right? Because that's what I do. Nope. I want you to think about this. What didn't I do? I didn't identify the question. The question is, what is the area of the room? Now, hopefully you know how to find the area of a rectangle. And if you don't, then I guess this is as good a time as any. The area of a rectangle is just length times width. That's all. See, I know the width. My width is 8. What I need to know is the length. Well, this is going to be 2 times 8 plus 3. That's going to be 16 plus 3, or 19. There we go. So this particular hospital room is actually 8 meters by 19 meters. It's a very big hospital room. And what we're going to do for that is multiply, right? So we're going to take area is equal to 8 meters times 19 meters. Okay. The next thing we got to do is actually multiply 8 times 19. It does come out to be 152. You can do this by multiplying this out on a calculator, or just kind of the long way, 152. You could also take 20 times 8 and then take off one of the eighths. right? 20 times 8 is 160, and then 1 less 8 is 152. One other thing of note is notice that I'm multiplying 8 meters times 19 meters, and then that will get me 152 meters squared. What is the area of the room? 152 meters squared. I have answered the question. So that's my answer. All right. The triangular warning sign on a biohazard container has two angles in a ratio of 1 to 2. That just means that one of the angles is twice as big as the other. So if one of the angles is 10, then the other one would be 20, right? If one of them is 35, the other one would be 70, okay? And a third angle that's 24 degrees more than the sum of the first two angles. Now I could just jump in, but I got to read the question. The question says, what are the measures of the three angles? So my answer is going to be three different angles, right? So it's not just the first angle, it's all three angles. Let's go ahead and figure out what's important here. We have the first idea here is the ratio is 1 to 2. I've already explained that one of them is just twice as big as the other. And then we also know something else that's important is the third angle is 24 degrees more than the sum of the first two angles. Of course, this is right here. That's our equal sign. Okay. All right, let's go ahead and start to get a look at this. There's just like all these, there's a lot going on here. Okay. So our first two angles is, let's say, let x be the first angle. Okay. Well, if x is the first angle, then the next angle is going to be 2x. So we can define it, or I can just say let 2x be the second angle. Okay. And then it tells me that the third angle is 24 more than the sum of the first two. Okay, well, so that means that angle 3 is, wait, angle 3 is? Yeah, angle 3 is 24 more than, that part means we're going to be adding to it the sum of the first two angles. Well, I know the first angle is x and the second angle is 2x, and what I want is 24 more than that. So this would be x plus 2x plus 24. Here's my problem though, is, oh my gosh, I have so much here. What am I solving? I know I have x is the first angle, 2x is the second angle, and x plus 2x plus 24 is the third angle, but the third angle of what? Oh, look back at the beginning. A triangular warning sign. Wait a minute. I better draw a triangle. Let's just put a random triangle up here. And I could say that this is x, and this might be 2x's is very much out of proportion. And then angle 3 would be x plus 2x plus 24. Well, what do you know about a triangle? Hopefully, and if you don't know this, now you do, that the sum of the interior angles of a triangle all add up to be 180 degrees. Whenever we're working in Euclidean geometry, which we're going to be working in Euclidean geometry in this class, don't worry about it. If you really want to have some fun, you can look up some non-Euclidean geometry. But for what we're doing, triangles all have 180 degrees, every one of them. That triangle does. You could have long, skinny triangles like that. That's 180 degrees when you add them all up. When you add up those interior angles, that has 180 degrees when you add up the interior angles. So this is just a fact. There's 180 degrees on this when you add up the interior angles of a triangle. So now if we add x, whoops, let's not do that. If we add x plus 2x plus x plus 2x plus 24 equals 180. There. Now I finally have an equation. X, I'll write this a little bigger, plus 2x plus, and then this is x plus 2x plus 24. Okay, when we combine all the like terms, I have x plus 2x plus x plus 2x. That's going to be 6x plus 24 equals 180. I'll subtract a 24 from both sides. Get 6x equals 156. And then divide both sides by 6. And that's how I'm going to get my first angle measure, which is going to be, let's see, if you take 156 divided by 6, that's going to be 26 degrees. The second angle, which I can just write like that, is going to be 2x, or double that. So 26 times 2 is 52. And then the third angle, I could find it a couple different ways. I could add those two and subtract it from 180, or I can add 26 plus 52 plus 24, because it said the sum of the first two and 24 more than that. So that gets me 2. How about 102? That sounds pretty good. There we go. What are the measures of the three angles? 26, 52, and 102. Last one. A cell phone battery is at 100% at 8 a.m. in the morning. After 10 hours, it's down to 24%. At what time, to the nearest minute, will the battery hit 0% if the average rate stays constant? My question says, at what time? That means my final answer is going to be a time on the clock, not 3 hours and 12 minutes, but it's going to be an answer like, oh, maybe it's 1:34 p.m. because it says at what time. Okay. Now, next thing we're going to look at here is we got to think of this as almost, these are like ordered pairs. So I have at 8 in the morning, it's 100%. Okay. I think I'm going to treat 8 o'clock in the morning at time 0. So you might even think of this as, hey, at 8 o'clock in the morning, we're at 100%. And then it says 10 hours later, we're at 24%. So 10 hours later, we're at 24%. And what's going to happen here is we're going to say that the drain on the battery is going to be a constant. So it's just going to come right through there. And at some point, we don't know when, it's going to reach 0. The life of the battery will reach 0. We are looking to try to figure out when this is. Okay. So let's figure out how much of the battery drains really each hour. Okay, so what happens here is this goes from 100% down to 24%. So 100, I'm going to do it this way. 100 minus 24 is 76%. The battery changes by 76 percentage points over the course of the day. And that's over 10 hours. Now, if you're using what's called the slope formula, there's a thing that we can do that looks like this, where we'd say like y2 minus y1 over x2 minus x1. And if we want to do it this way, that's no problem. Because what our ordered pairs are is 10, 24, and we also have 0, 100. Okay, so this would be 24 minus 100 over 10 minus 0. That's negative 76 over 10, or negative 7.6 percentage points per 1 hour. Okay. Notice that mine originally just has 76% over 10, right? And this would be 7.6 percentage points per hour. That's fine. And this other one has negative. That's fine too. You just have to make sure that you understand that this is a loss, or it's decreasing by 7.6 percentage points per hour. Okay? Just like with all these problems, there's several different ways that you could do this. One would be to say, hey, after 10 hours, I'm already at 24%. How many more hours to get down to 0% if I'm losing 7.6% each hour? And if I take 24% remaining and I divide this by 7.6 percentage points per hour, okay, what I end up getting, if I put that in the calculator, is I'm going to get, let's see here. Let me do this on a calculator, because I get 3.15789 hours after the 10 hours. So that's from here to here is 3.15789 hours. Now, what I want to know is this 3 hours, that's easy. That's no problem. But I want to know how many minutes is this. So what I can do as well is to take 0.15789 of an hour. And of means multiply, so I'll take that times 60 minutes in an hour. And when I do that, I get about 9.47 minutes, or about 9 minutes. So this right here, this 3.15789 hours really turns into 3 hours and 9 minutes after the 10 hours. Okay, so in total, if this is 10 hours from the start until 10 hours later, then that means that this total is going to be 13 hours and 9 minutes after 8 a.m. Now, this can also be a little bit challenging, but what I would like to do is maybe instead of doing 13 hours and 9 minutes all at once, why don't we go 12 hours? So I can take 8 a.m. and then we'll say like plus 12 hours. We'll make it 8 p.m. Now I need to add on 1 hour and 9 minutes, or 1 hour and 9 minutes after 8 p.m. That turns this into 9:09 p.m. So that's when my phone battery is finally going to die. Now, this is one way to do it, and that's referencing this point of after 10 hours of playing on the phone, I'm at 24%. So what I'm really looking for is how long until that 24% goes to zero. Another thing we could have done would have been to write this as a linear equation. So we could have, let me clear out some of this, and I'm gonna get a little clock here just kind of as a picture to kind of help out. But what we could have also done would have been to say y equals my slope of negative 7.6 percentage points per hour. And then my initial value was 100. So that's this spot right here. And what we're looking for is when our power or battery life is 0. So we can put 0 in for the y value. And then this really is kind of the same type of problem. We're just going from starting from 100 instead of starting from 24 percentage points. When we divide this out, and I divide both sides by negative 7.6, I get x is equal to 13.15789 hours after the start, which that's what we had here as well. So 13.15789 hours after 8 a.m. is still 9:09 p.m. Whew. All right, that's a lot. Well, good luck with this. Go back and rewatch some of it. And remember to pause the video, and especially once you know where you're going with it, pause it and make sure that you can get there on your own, or find some more help.